the final part of chapter 20, induced voltages and induced currents, is figuring out which way the induced current will be. All right? So here's the lecture on how you figure it out. You're going to need to see multiple examples. I have 2 examples here on this screen, although you're going to need to see more examples. Like you'll see them in the homework set. You got to sit with it and think how you're going to do the induced current. So here's how you figure it out. It's a law called Lenz's law. Now, the induced current in a loop, the good news here is you got a 50-50 chance. The induced current is either going to run clockwise in the loop, or the only other possibility is counterclockwise in the loop. So if you never fully understand this, you know that there's only 2 options. That's a pretty good chance, 50-50. You know, on the typical multiple choice, A, B, C, D, E, you got a 20% chance. Here you got a 50% chance. But if it's on the FRQ, just make sure you mention Lenz's law. You say, if they're asking you for the direction of the induced current, you say, according to Lenz's law, the induced current will be, and if you understand it, give it the right answer, and if you don't understand it, just take a stab in the dark. It's either going to be clockwise or counterclockwise, one or the other. All right, now how do you do it? Here's what Lenz's law says. The induced current in a loop creates a magnetic field that is opposite the change in magnetic flux. So first thing I want to point out here is there are 2 magnetic fields going on. There are 2 of them. So look at this situation right here. Let's just look at this one right here, okay? So obviously we have the magnetic field that's given in the problem. That's the first magnetic field. What's the second magnetic field? The second magnetic field is the magnetic field produced by the induced current. Remember from chapter 19, if you have current in a wire, what is that going to create? A magnetic field. So once you get an induced current, once an induced current starts flowing, around the loop, that's going to create a second magnetic field. There are 2 magnetic fields going on here. All right? The induced current creates a magnetic field that is opposite the change in flux. So here are your 2 steps. Step 1, determine the direction of the change in magnetic flux. Which way does the magnetic flux change? Once you've identified that, go to step 2. Step 2, use right-hand rule number 2. Now, do you guys remember right-hand rule number 2? It's the one where your thumb is the current and your 4 fingers are the field. So like for a straight wire right here, if it's a nice straight wire, you stick your thumb in the direction of the current. The way that your 4 fingers curl, that's the direction of the magnetic field. Okay? So use right-hand rule number 2 to determine the direction of the induced current. So let's do an example here. Let's start with this. So I got 2 situations. So let's start by looking at this situation. This metal rod is being pulled to the right. So what's happening to this area? The area, is it increasing in size or decreasing in size? It's increasing. Is that letting more magnetic field into the loop or less magnetic field into the loop? If this bar goes to the right and the area opens up, is that allowing more magnetic field in or less? More. It's allowing more magnetic field into the loop because the loop is getting larger. Would you consider this, with the bar moving to the right, would you consider that change of magnetic flux to be in or out? What do you think? The change of magnetic flux. It's letting more magnetic field in to the loop. The change of magnetic flux is in. Dudes, the analogy I like to make, pretend that this, instead of being like a metal rod, instead of it being a metal rod in a magnetic field, I want you to imagine that this is a door to a concert, right? And this is the doorway right here. And instead of the X's being a magnetic field, the X's represent people going to a concert. If this door is moved to the right, is that going to let more people into the concert or less people? more people in. You're letting more in. The change in the flux is in. Okay? All right, let's go to step 2. Step 2, so the induced current, don't get up yet, the induced current is going to create a magnetic field that is what? Out. So you got to do right-hand rule number 2. Here's a loop for you guys. Magnetic field from the induced current is opposite the change in flux, which is out. Which way is my thumb pointing? Counterclockwise. The induced current here is going to run counterclockwise. Hey, I know the bell rang. Listen, just real quick. Let's go to this one. Here we have a situation. I'm telling you the B field is into the page and decreasing in magnitude. Which way is the change in flux here? If the magnetic field is decreasing in magnitude, it's going to be out. The change is out. So go to step 2 now. Step 2, use right-hand rule number 2. So the induced current makes a magnetic field that's in. Which way is my thumb pointing? Right-hand rule number 2. It's going to run clockwise. Like that.